All right, try it 2.12. I have a line. I don't know the equation of the line, which is kind of unfortunate, but there's some line out there, and it goes through these 2 points. And what I want to do is find the equation of a totally different line. And this different line that I'm trying to figure out the equation of, well, it goes through this point, and it's perpendicular to this first line. Wow, okay. This is about the most confusing and strange way you could be given all the information that you need to come up with the equation of a line, but we do have everything we need, because to figure out the equation of a line, we need to know the slope and 1 point. I'm given 1 point right here. That's fantastic. All I need to know is the slope of this line that my answer will be. And while it's not explicitly given to me, I'm told that this line is perpendicular to this line. So if I could figure out the slope of this line, I could figure out the slope of this line because it's perpendicular. So really what I want to do is figure out the slope of this line over here. The slope of the line that I'm not looking for the answer. So maybe I can color code these. I got a line, and maybe I'll circle this in red, that goes through these 2 points. So let's figure out the slope of this line using our slope formula. Well, if I arbitrarily name these points, I'll call this x1, y1, and this x2, y2. And then plug them in up here. Y2 is -3, minus y1 is -15, divided by x2 is 2, minus x1 is -2. So I got -3 minus -15, which is the same as -3 plus 15, which is +12, divided by 2 minus -2, which is the same as 2 plus 2, which is 4. So I know that the slope here is 3 because 12 divided by 4 is 3. But that's not the slope in green. Because in green, my line is perpendicular to this line. So what that means is the slope in green is the negative reciprocal of the slope in red. So if you think about this as 3 over 1, what I want to do is invert that fraction, flip that fraction upside down. Now it's 1 over 3. And then change the sign. Since this used to be positive, it's now going to be negative. I know the slope and I know a point. I have everything I need to come up with the equation of that line. I'm not given the y-intercept, unfortunately, with this point. So I'll have to do a little bit of work. I will use point-slope form because I have a point and I have a slope. So I got y minus y1 equals m times x minus x1. And note, you better not use this x1 and y1 here for x1 and y1 because these points were on the red line and I want the green line. So I'm going to call this x1 and this y1 and use those two and this slope down here in green. So I got y minus 4 equals m, which is -1/3. So I don't need that parenthesis out in front. Times x minus x1, which is 6. And the way I like to do these, I like to first get rid of the parentheses. So I got y minus 4 equals -1/3 x. And then -1/3 times -6. Negative times a negative is a positive. And 1/3 times 6 is 6/3, aka 2. And that's because you can think about this as 6 over 1. And so 1 times 6 is 6, and 3 times 1 is 3. Anyways, that gets you here. Add 4 to both sides of the equation, and you get y equals -1/3 x plus 6, which I think is a perfectly fine answer, but technically, it doesn't say to write it as a function, so we're good then. Let's call this good. You could have written f of x equals if you feel like it. We are kind of dealing with functions here, but since it doesn't specify to write it as a function, I think this is a perfectly good answer. -1/3 x plus 6 there. You could check your answer if you felt like it. You could throw this point in here and make sure things work out. You can kind of look at this guy and make sure that it is in fact perpendicular. I'm sure there's things you could do, but I'm going to go ahead and call this good.